There's a new AI hidden inside macOS right now. Apple ships it. It runs right in your terminal and almost nobody knows it's there. So I had to know, how fast is this thing really? I'm gonna try it on this Mac Mini that I just upgraded to macOS 27, the beta version. Keep that in mind, it's beta. And how much faster is this tool gonna be running it on an M3 Ultra Mac Studio instead of the Mac Mini? Let's find out. Quick detour before we get back to the video. I wanna show you this thing called Super Nori, and it's one of the first proactive family AI agents I've seen. And for a tech audience, I think the important frame here is that it's meant to run in the background around a real family context. A lot of helpful AI these days still depends on you noticing the issue first, then writing the prompt, then managing and following up. Even when the tools are good, they still assume the right person catches the problem in time and manually kicks everything off. So now there's Super Nori from the team behind Nori, which is already used by more than 200,000 families. Instead of waiting for a prompt, it watches for situations that need attention, and it surfaces the next step while there's still time to do something about it. So at 6 a.m. traffic is already a mess. It can catch that before you do and ask you if you want to book the ride. And later on in the evening, if a last-minute calendar change is about to blow up your anniversary dinner, it doesn't just stop at noticing the problem. It can start finding backup options before the night falls apart, even making another reservation for you. What makes this interesting to me is that it's a cleaner example of what people mean when they say agent instead of just assistant. It's built to ask before acting, which matters when you're talking about real-world decisions. So, like your coding agent takes care of your code base and proactively finds issues and bugs, Super Nori is the agent that looks after you and your family. You can check out Super Nori in the link in the description below and join the waitlist from there. Okay, let me back up for a second. So macOS 27 Golden Gate quietly ships this thing called FM. It's a built-in CLI that runs actual large language models? Not sure. I think it's just one model, but there's two ways of running. There's a cloud version. I'm gonna get into it. Hold on a second. Basically, as soon as you have macOS 27 installed, you just have it right there in your terminal available. There's no need to install things like llama or LM Studio or MLX. Well, hold that thought. There might still be a need. But for a developer, that's kind of wild. It's basically a free private AI endpoint just sitting right there inside the OS. And it's all local. You can script it, you can build tools on top of it, whatever you want to do. So I had 3 questions. Can you actually use this thing? How fast is it? And the big one, the one I actually care about, does throwing more expensive hardware at it make it any faster? And to answer any of that, I needed some real numbers. So I went to benchmark it. Easy, right? Right away, I hit a wall. I grabbed my favorite bencher for LLMs, Llama Benchy. I pointed it at FM, and it told me Apple's little built-in model was doing 600,000 tokens a second. That's for prompt processing, and decode was 22,000. Come on, really? That's definitely not a benchmark. That's a typo. Here's the thing. It's not really the tool's fault. Apple's server, Apple being Apple, they have to be a little bit different. They don't exactly comply with the OpenAI standard all the way. Some things do, like /models, but of course they had to have their own thing. And Llama Benchy is designed to work with OpenAI compatible endpoints. So Apple's server doesn't just hand back timing numbers these benchmarks expect. Bottom line, nothing off the shelf can actually measure this thing, except maybe Apple's own proprietary internal stuff. So fine, if nothing out there can do it, I'll build my own. So I created Apple FM Bench. But hold on, don't go running out there yet and grabbing it. I'll explain. I will link to it in the description, of course. Now, here are the actual numbers you get from this. About 1,150 for prompt processing and about 52 for decode. That's the generation stage. All on device. And I'm talking about the Mac Mini right now. So, FM has 2 brains, though. There's the local one running on your Mac, and then there's the Apple Cloud one called Private Cloud Compute, which is going to the cloud. So, private, local, cloud. I'm not sure, okay, how to explain that. Basically, the FM tool, it does both. And you can specify whether you want to use the cloud one or the local one. Cool. So I tested both. And the cloud is about 3 times faster than the local one. That's good to know. But really, the local model is the one I really care about the most, because that's the one that's running on your hardware. And that got me thinking, if it runs on my hardware, wouldn't a beefier Mac just run it faster? So on one side, on the left, I got the Mac Mini, this one, and on the right, I got the Mac Studio, that one. Now the M4 Pro, which is what this is, it has 273 gigabytes per second memory bandwidth, and memory bandwidth is very important when it comes to generating tokens, the decode stage. It also has a pretty nice little GPU inside for processing. That's the prompt processing stage. By the way, if you don't know what I'm talking about, I explained this in a bunch of other my videos. Inference, when you're doing the LLM stuff, when you're using them, there's two stages. One is prompt processing, that's the first stage, and the second stage is the actual generation of tokens. The first stage is also called prefill, the second stage is also called decode. Now you're all caught up, but you can still go watch my videos. Anyway, this one has the memory bandwidth of 819. It's the M3 Ultra. It's the biggest right now that Apple has, the fastest memory bandwidth. 819 versus 273. That should be much faster. So I figured it was gonna bury the Mac Mini. So here's the M4 Pro Mac Mini. Prompt processing chart is on the left, decode chart is on the right. Let's look at the on-device stuff, all right? So for on-device, 1,142, and on-device for decode, 56. Now, if we take a look at M3 Ultra Mac Studio, what the, huh? I'm just kidding. I already knew this because I already made the chart, so my reaction was kind of lame, I guess. But how about your reaction? Is this what you expected? Because this is, the first time I saw this, I was like, what? We got the same numbers pretty much on both machines. Those Mac Studios go for like 10 grand each. Well, these do down here. This one I got on sale for 4,000. But still, a huge difference in the hardware here. That is tied to the Mac Mini. Are you serious? So now I had a kind of a mystery on my hands. Why would these two be pretty much the same? And I had a hunch that it was probably running on the neural engine, the ANE, or Apple Neural Engine. That's the NPU. And the reason is it's basically the same block of silicon across M3 and M4. That would explain it perfectly. So I wanted to confirm it real quick. This is MacTop, and MacTop is basically one of the applications, there's several of them, that show the current usage on the terminal of the CPU, the GPU, the ANE, and then the memory used. And it's loosely based on AziTop, which I have running over here. They are very similar. Actually, I don't have that running at the moment because you can only have one of them running at a time. But AziTop is an oldie. It came out when Apple Silicon first came out, and it showed the ANE. And for a while there, it showed it quite nicely. Until now. So I watched the neural engine while FM is running, and it stayed at 0 the whole time, 0%. I tried it with AziTop, I tried it with MacTop. So much for that theory that I was using the ANE, right? I was now starting to think that this was the GPU that was doing it, but something bugged me. The numbers just didn't feel right. So instead of testing FM directly, I tested the tools. I built a little workload that has to use the neural engine. If you use Core ML model and you run it, and of course I had Claude Code help me with that because I never touched Core ML before. Core ML is going to be using the neural engine. I ran it, and guess what? AziTop, MacTop, 0. In fact, AziTop and MacTop use Parametrics under the hood. That's Apple's own CLI utility. And Parametrics also told me the CPU was pulling 0 watts while it was literally running the test, which is impossible. So I ran the same model two ways. One is neural engine on, and the other one is neural engine off. With the neural engine on, it was over 2 times faster, which means that for FM, the neural engine is absolutely working. It's doing real measurable work. And every single tool that I use to measure the ANE is just not seeing it. All right, new plan. If I can't trust a single meter on these machines, I'll stop using the meters entirely and I'll make the engines fight. Here's the idea. I run FM, and while it's running, I hammer the neural engine as hard as I possibly can. If FM slows down, it's fighting for the ANE. Then I'll do the whole thing again, but this time I hammer the GPU instead. Whatever drags FM down tells me which engine it's really using. And folks, the result was beautiful. When I hammered the neural engine, FM's decode slowed down. Prompt processing didn't move a bit though. And when I hammered the GPU, FM's processing slowed down. That's this blue line right here. And decode didn't move. Each one hits exactly 1/2, clean as it can be. And that right there is proof with no meters at all that FM's decode runs on the neural engine. And its prompt processing runs on the GPU. So that's why the Studio couldn't beat the Mini. Decode is on the neural engine, and that's basically the same exact chip across the M3 and the M4, and even the M2 and the M1, I believe, well, the M1, I think I had a different one, but the M2 to M5 all have that 16-core neural engine. So all that extra power just sitting around doing nothing on the Mac Studio. So basically, if you're running Apple's built-in FM tool, a Mac Mini gives you the same exact experience as the maxed out Mac Studio. Same speed, fraction of the price, save that money. Or you can spend it on something that actually scales. For example, remember I talked about other things like llama.cpp, which is basically what LM Studio and Ollama use under the hood, and MLX especially. MLX is Apple's own framework for doing LLMs. And MLX absolutely does use that big GPU. I made a bunch of other videos about it, link down below. By the way, did you even know that macOS had this thing called FM hiding inside of it? Let me know down in the comments below. And the tool that I built to test all this, Apple FM Bench, is free on GitHub, link down below too. Go run it on your own Mac and tell me what you get. Although I have a feeling that you're probably gonna have the same results. Oh, and just a heads up, this is still in beta, of course, and it will never run on anything other than Apple Silicon. So Intel Macs, it's not gonna work because Golden Gate doesn't do Intel Macs. Also keep in mind that since this is beta, Apple can change this anytime. They can even change it after release. They can have it use a piece of the GPU later on. Now, if you want to see some bigger and chunkier models running on Apple Silicon, watch this video here. Thanks for watching, and I'll see you next time.